Good morning to all. Today we are going to see about external conditioning for boiler feed water. It is also called as external treatment. It can be used to remove the hardness producing salt from water before feeding into the boiler. In this treatment can be done in two processes. First one ion exchange process, second one zeolite process. In this ion exchange process is otherwise called as demineralization process or deionization process. In this process, to remove all the ions like both the cations and anions, all the ions present in the hard water. The soft water produced by zeolite process does not contain hardness producing calcium, magnesium ions, but it contains other ions like sodium, potassium, sulfate, chloride, etc. On the other hand, demineralized water does not contain both anions and cation. It is one of the important points. The demineralized water does not contain anions and cation. Only hard water contains the anions and cation. Thus, the soft water is not demineralized water, whereas a demineralized water is a soft water. So, when we using this ion exchange resin to prepare a resin, ion exchange resin. In this demineralized process carried out by using ion exchange resin, which are long chain, cross-linked, insoluble organic polymers with a microporous structure. In this resins contain a microporous structure. The functional groups attached to the chains are responsible for the ion exchanging properties. It has two types. First one is cation exchange resin, or it is also called as cation exchanger. Second one is the anion exchange resin. It is also called as anion exchanger. First one, cation exchanger or cation exchange resin. So these resins contain a acidic functional group like COOH, SO3H, like acidic functional group. They are capable of exchanging their hydrogen ions with the other cation of hard water. The cation exchanger resin is represented as RH2, or containing a alkyl group. For example, styrene divinyl benzene. It is also called as a polymer. It can be sulfonation become capable of exchanging their hydrogen ions with the cations of solution. So we add the resin to the hot water. The resin absorbs the calcium ions in the water to removal of hydrogen ions. They are given below two examples. One is calcium, second one is a magnesium. So the resin absorbs the calcium and the magnesium ion to the removal of hydrogen ion. So second one is a anion exchanger. The functional group of anion exchanger is NH2 or OH or NH4. These are capable of exchanging their anion with the other anions of hard water. It is also represented as ROH or ROH twice. It has been given two examples. First one is a removal of chlorine. Second one is a removal of sulfate in the hard water. So the process, this is the setup of ion exchanger. First denoted as a anion exchanger, second one denoted as a first one is a cation exchanger, second one is a anion exchanger. The hot water first passed through the cation exchange column, which absorbed all the cations like calcium, magnesium, sodium, potassium, like that. Then the cation free water is passed through the anion exchanger column. It absorbs all the anions like chlorine, sulfate, hydrogen chloride, like that. So in this process, the two reaction can be occur. First one is a cation exchanger, or H2 reacts with the calcium chloride to form RCA, then removal of hydrochloric acid. Second one is a ROH twice reacts with the hydrochloric acid to form RCl2 in the removal of water. The water coming out the anion exchanger is completely free from cations and anions. This water is known as demineralized water or deionized water. So, how to regenerate the resins? When the cation exchanger resin is exhausted, it can be regenerated by passing a solution of dilute hydrochloric acid or dilute sulfuric acid. So, these resins can be prepared by RCA. Alkyl RCA reacts with the hydrochloric acid to form OH2 and calcium chloride. Similarly, when the anion exchange resin is exhausted, it can be regenerated by passing a solution of dilute sodium hydroxide. The advantages of ion exchange resin is it highly acidic or alkaline water can be treated by ion exchange process. Second one is the water obtained by this process will have very low hardness like 2 parts per million. So third one is in addition of calcium and magnesium ions, it removes all the ions like sodium, potassium, sulfate, then chloride, etc. Then the disadvantages of ion exchange process. First one is water containing turbidity, iron and manganese cannot be treated. When the hard water containing iron and manganese, the water cannot be treated by ion exchange process because the turbidity reduce the output and iron magnesium from stable compound with the resin. Second one is equipment is costly and more expensive chemicals are needed. Thank you.